All right, in this video, we want to find the composite functions of these two functions, basically f of g of x and g of f of x. And once we find the composite functions, we want to find the domain, the range, and the vertical asymptotes of each function. So let's start with f of g of x, which is just f of 1 over x, which is just the log of 1 over x plus 1. So let's start by talking about the vertical asymptotes of this function over here. The vertical asymptotes for this function, if I have a log function, that's just a plain log, and then I have some kind of equation here and then a constant, I know that this basically this d value over here is going to give me a vertical asymptote at x equals to -1. It doesn't matter what type of function there is here, whether it's x squared or 1 over x squared or things like that. We're always going to have a vertical asymptote at x equals to -1 because of this value over here. And that's because this is just overall a log function. And we're also going to have another vertical asymptote because we cannot have 0 in the denominator of a reciprocal function, which means we have a second vertical asymptote at x equals to 0. Now, the next thing I want to do is I want to solve for the domain and range of this function. So let's start with the domain. To find the domain of a log function, you can just put the inside of the log function and make it greater than 0 because the inside of a log has to be greater than 0. Then we can just solve this and include our vertical asymptotes as well. And that will basically give us our domain of the function. So in order to solve this, I want to make a common denominator. First, I'm going to multiply by x on the top and bottom here. So I have 1 plus x over x is greater than 0. And then my vertical asymptote is just a 0, so that's already included over here. And then the solution to the top is -1, which is also a vertical asymptote in this question. So my two solutions to this, x equals to 0, x equals to -1, are basically my vertical asymptotes. I'm going to put these on a number line. I'm going to solve this using a number line to find my domain. So I'll start by picking a value less than -1. I'll pick -2. If I sub in -2 in this equation, I'll get -1 divided by -2, which is positive half. Positive half is greater than 0, which means this entire region of my domain is good. And then if I pick a value between these two, I'll pick -0.5. If I sub in -0.5 here, I'll get -1. -1 is not greater than 0, so this is no good. And I'll pick a value above 0, pick 1. 1 plus 1 is 2. 2 divided by 1 is 2. 2 is greater than 0, so this is good as well. That means that my domain is x is an element of all real numbers such that x is less than -1 or x is greater than 0. Now I need to find my range of my equation. So in order to find my range, I'll basically sub in my n behaviors and see what's happening. So if we take a look at this function here, we have a log function, and yeah, I've got to just sub in my n behaviors. So I'm going to start by plugging in f of -100 in this equation. So if I sub in -100 log of 1 over -100 plus 1, it's basically a really small negative number. Gives scientific notation, it's like -0.000436. Oh, too many zeros. This is just approaching 0, basically at the negative n behavior. Then I'll sub in a value slightly less than my first asymptote, so I'll do f of -1.1. And if I put that in my calculator, I get negative 1.04. Maybe I should pick something slightly small like f of negative 1.01 to see what's happening. Sub in negative 1.01, I get negative 2. So this is going to keep getting larger and larger as this gets smaller and smaller or closer to the asymptote, which means this will eventually go down to negative infinity. So I know that for the negative side of this equation, it's going from basically 0 to negative infinity. Now let's go to the other side of the asymptote from 0 to positive infinity. I'll sub in f of 0.01. And if I do this, I get positive 2. So this is basically approaching from the top. So if you think of the graph of this, it's kind of what I'm doing. We have a vertical asymptote at negative 1, and then this side is just going like that. And over here on the right side, we are approaching from the top of the asymptote for x equals to 0. There's nothing in the middle over there. That's just empty space. And then I'm going to do my n behavior here. So f of 100, but I'm just expecting to be a very small value, slightly larger than 0. And yes, that's basically the case. It's 0.00436. So this is just approaching like this. So the range of this function, we can tell from this graph over here, is that y is an element of all real numbers such that y cannot equal to 0, because y basically takes every positive and every negative value. Only value it doesn't take is 0. Okay, let's go to g of f of x. So g of f of x is g of log x plus 1, which is basically 1 over log of x plus 1. I need to find the vertical asymptotes, the domain, and the range of this function. This one is a pretty tricky one. So we know that we're going to have a vertical asymptote. So this is not an overall log function. Okay, this is just simply a reciprocal function with a log in the denominator. So we're not going to have an asymptote at negative 1 like we did for the log function. This is just a log function. This is a reciprocal function with a log in the denominator. For this one, to find the asymptote, we have to do the denominator equals to 0, because wherever the denominator equals to 0, that's going to be a vertical asymptote, and we need to solve this. I'm going to move the log to the other side. So x plus 1 equals 10 to the power of 0. 10 to the power of 0 is just 1, and 1 minus 1, x equals to 0 is the vertical asymptote for this composite function here. So we only have one vertical asymptote in this function. I'll do a sketch of this one as well, just so that it makes things a bit easier in terms of the domain and range. So we only have an asymptote at x equals to 0. So now we need to figure out the domain of this function. The domain for this function, there's no restrictions for the domain of a reciprocal function other than it cannot be equal to the vertical asymptote, which is 0 in this case. But for this log function in the denominator, I know that the inside of the log function has to be greater than 0, which means x has to be greater than negative 1. Okay, so what does this mean? This means that x has to be greater than negative 1, but it cannot equal to 0. So our domain is x, e, r, such that x has to be, so negative 1 less than x less than 0. So that's from negative 1 to 0, comma, x is greater than 0. So we go from negative 1 all the way till positive infinity, but we are not including 0 in our solution because 0 is a vertical asymptote. And to find the range of this question, again, we just need to test our n behaviors over here. So in order to test our n behaviors, we're going to sub in values into this function, see what we get. So I'll start with the negative most n behavior, which is going to be close to -1 because my lowest possible value has to be greater than -1. So I'll do f of -0.99. Let me put this in my calculator in the original equation over here, 1 over log -0.99 plus 1. That's just -0.5. So basically, this is just approaching 0. This is really close to 0. If you pick a smaller value, you'll get a value even closer to 0. Okay, but it never actually hits 0 because technically it's impossible to have 0 in this case. Because you cannot log, if I put -1 here, -1 plus 1, you cannot log 0. So next I'll test my vertical asymptote. I'll test -0.01 to see what's happening over there. And I'll even put this point over here, which is just here at -1, but slightly below. And it keeps getting closer to 0, but it never basically hits 0. Okay, so if I sub in -0.01 in this equation, I get a huge negative number, -229, which means this is just going down towards the bottom like this at the asymptote. Then I want to do positive 0.01. If I put in positive 0.01, I will get positive 231, which means that this graph starts on the top here and it's going down. Most probably it's going to hug a horizontal asymptote, but you want to test that, make sure. So you want to test f of positive 100 for your n behavior. And f of 100, if I put that in my calculator, again, I get 0.5, which is basically going to hug the positive side of the asymptote. So again, over here, our range is just y does not equal to 0. So range y is an element of all real numbers such that y does not equal to 0. Y values take every other positive and negative value possible.